Look up at the night sky on a clear, moonless evening. You see a brilliant tapestry of light. Thousands of stars, glowing filaments of dust, the faint, ghostly smear of the Milky Way stretching across the horizon. It feels overwhelmingly crowded. It feels as though we are part of a bustling, densely populated cosmos, an intricate web teeming with matter, gravity, and ancient structure. This is perhaps the greatest optical illusion in human history. The light reaching your eyes is a comforting lie born of perspective. We are not standing in the vibrant metropolitan center of the universe. We are marooned in the deepest, darkest cosmic wilderness imaginable, completely enveloped by an anomaly so vast that our foundational models of astrophysics struggle to justify its existence. Imagine looking out the window of a brightly lit room into a pitch-black winter night. The glare on the glass reflects the warm interior, making the room feel infinite and hiding the terrifying, freezing emptiness just beyond the pane. For centuries, our telescopes have been staring at that glass. We mapped our local stellar neighborhood. We tracked the movements of our neighboring galaxies, and we naturally assumed the rest of the universe mirrored our immediate surroundings. We built our entire understanding of reality on the assumption that the cosmos is fundamentally uniform. But as our instruments grew sharper, piercing deeper into the ancient dark and measuring the residual radiation left over from the dawn of time, the observational data began to whisper a deeply unsettling truth. The measurements revealed a critical deficit, a massive, inexplicable absence of mass. If you were to cast a wide net across the observable universe, measuring the average density of galaxies and dark matter, you would establish a baseline weight for reality itself. But when we measure the local region of space encompassing our galaxy, that density violently plummets. We are suspended within a colossal sphere of profound nothingness, a region stretching nearly 2 billion light-years across. We exist in a localized desert, where physical matter is drastically sparser than the universal average. We are not merely drifting through the endless expanse of space. We are anchored deep within what astronomers call the KBC void, a structural abyss so overwhelmingly empty that it threatens to break the standard cosmological model we rely on to make sense of creation. The glowing stars you see above are nothing more than scattered dust motes floating in the center of a silent spherical tomb. And for the entirety of human existence, we had absolutely no idea we were buried inside it. If you are drawn to the terrifying scale of reality, if you seek the cold, unfiltered truth of the cosmos hidden in the dark, then subscribe and join us on this journey. There are no comforting illusions here, only the magnificent, relentless indifference of the universe. As we begin to peel back the layers of this profound cosmic isolation, we must first confront the mechanics of our own blindness. To understand how an entire civilization could fail to notice the invisible walls of its own cage, we have to look back at the fundamental assumptions that defined human science and the exact moment our intuition began to fracture under the weight of the dark. To understand the magnitude of our deception, we must first examine the architecture of human intuition. We are creatures forged by gravity and friction, evolved on a dense, rocky sphere where matter is packed tightly together. Our brains are hardwired to process immediate, tangible environments. When we stand in a crowded city or walk through a dense forest, we subconsciously project that localized density outward into the cosmos. We look at the scattered diamonds of the night sky and assume they are simply the visible suburbs of an infinitely sprawling, equally populated galactic metropolis. But intuition is a localized survival tool. It is entirely useless when confronting the staggering, indifferent scale of the universe. For centuries, the bedrock of modern astrophysics was built upon a deeply comforting philosophical assumption known as the Copernican principle. Following the revelation that the Earth was not the center of the solar system, science adopted a profound humility. We accepted that there is nothing special or privileged about our position in the cosmos. In the early 20th century, as our telescopes began to resolve faint spiral smudges in the dark as entirely separate galaxies, cosmologists expanded this humility into the ultimate foundational law of reality, the cosmological principle. The cosmological principle dictates a beautifully elegant mathematical rule. It states that on a grand enough scale, the universe is both homogeneous and isotropic. It means that no matter where you are in the universe, and no matter which direction you look, the grand tapestry of space should look roughly the same. Imagine looking at the surface of the ocean. If you are floating in the water, the surface is chaotic. You see towering, unpredictable waves, deep troughs, and swirling currents. The local environment is highly irregular. But if you were to view that exact same ocean from the silent orbit of a satellite, the waves vanish into a perfectly smooth, uniform sphere of blue. Cosmologists believed the universe operated on the exact same logic. Up close, sure, matter clumps together into stars, galaxies, and clusters, governed by localized gravity. But if you zoom out far enough, to a scale of hundreds of millions of light years, those individual galaxies should blur into a perfectly smooth, evenly distributed fluid of matter and energy. This assumption was not merely philosophical. It was the crucial load-bearing pillar for the entire mathematical framework of reality. The equations that describe the expansion of space and the evolution of time fundamentally require this universal smoothness to function. If the universe were fundamentally lopsided or plagued by massive, unpredictable irregularities, the gravitational math governing the cosmos would become a chaotic, unsolvable nightmare. We needed the universe to be uniform, not just for the sake of elegance, but so our equations could successfully map the past and predict the future. And for decades, the observational data seemed to validate our hopes. Throughout the 20th century, astronomers embarked on the most ambitious cartography project in human history. Using the Doppler effect of light, they measured the redshift of distant galaxies, calculating how fast these colossal islands of stars were receding from us as the very fabric of space stretched outward. They began to map the architecture of the cosmos. What they found was mesmerizing. The universe was not a random scattering of galaxies, but a complex three-dimensional cosmic web. Dark matter, the invisible scaffolding of reality, had pulled normal matter into colossal, glowing filaments, stretching across billions of light years. Where these filaments intersected, massive superclusters of galaxies formed, burning fiercely in the dark. And between these blinding threads of light lay the voids, vast, empty, spherical regions where matter was scarce. But even with the discovery of the cosmic web, the cosmological principle held strong. The math still worked. Theoretical physicists calculated that there was a strict physical limit to how large these empty voids could possibly grow. The gravitational mechanics of the early universe dictated that a void could perhaps stretch a few 100 million light years across, but eventually you would hit the walls of the next galactic filament. If you took a large enough sample of the cosmic web, encompassing both the bright filaments and the dark voids, the average density of the universe still smoothed out perfectly. The ocean, viewed from orbit, was still uniformly blue. We believed we had deciphered the blueprint of creation. We were confident, we were arrogant. And then, at the dawn of the 21st century, our precision instruments began to register a ghost in the machinery. The fracture in our understanding did not arrive as a sudden, catastrophic discovery, but as a slow, creeping inconsistency in the most important measurement in all of physics, the rate of cosmic expansion. To understand the destiny of the universe, whether it will expand forever into a freezing, starless eternal night, or eventually collapse back in on itself, you must measure exactly how fast space is stretching. Cosmologists calculate this expansion rate using two entirely different, highly precise methods. The first method is the ultimate macroscopic view. By launching satellites into the freezing vacuum of space, we can capture the faint microwave radiation left over from the very first moments after the Big Bang. This ancient light acts as a pristine, uncorrupted fossil record of the early universe. By analyzing the microscopic temperature fluctuations in this background radiation, scientists can calculate the exact density of matter and energy at the dawn of time. From this primordial snapshot, the mathematics allow us to project forward, calculating exactly how fast the universe should be expanding today. It is a precise, elegant, and globally encompassing measurement. The second method is entirely local. Astronomers look out into our immediate cosmic neighborhood and measure the distances and velocities of specific, highly predictable exploding stars, type Ia supernovae. Because these dying stars explode with a consistent, mathematically reliable brightness, they act as cosmic lighthouses. By measuring how much the light from these local explosions has stretched as it travels toward Earth, we can calculate the current, real-time expansion rate of the space immediately surrounding us. For decades, we assumed these two numbers would perfectly align. After all, if the universe is uniform, the expansion rate predicted by the ancient background radiation should exactly match the expansion rate measured in our local cosmic backyard. But as our telescopes grew sharper and our measurements achieved agonizing, uncompromising precision, a terrifying discrepancy emerged. The two numbers refused to match. The measurements from the early universe dictate that space should be expanding at a specific, steady pace. But the observations of our local supernovae, exploding right here in our cosmic neighborhood, tell a completely different story. The data reveals that the space surrounding our galaxy is flying apart significantly faster than the rest of the universe. This discrepancy, known in physics as the Hubble tension, has become the single most agonizing crisis in modern cosmology. It is a mathematical paradox that threatens to unravel our entire understanding of physics. At first, scientists assumed it was simply human error. Perhaps the telescopes were calibrated incorrectly. Perhaps the interstellar dust was interfering with the light. But year after year, study after study, utilizing multiple independent observatories and entirely different sets of data, the numbers remained stubbornly, relentlessly apart. The math reveals a merciless truth. The localized fabric of space around us is tearing outward with an accelerated ferocity that the standard model of physics cannot explain. We are moving too fast. The local universe is behaving as if the gravitational anchors that should be holding it together have simply vanished. Faced with this mathematical nightmare, a controversial and deeply unsettling hypothesis began to take root in the darkest corners of theoretical astrophysics. If the localized expansion of space is outpacing the rest of the universe, there is only one physical mechanism that could cause such an anomaly: gravity, or rather, a profound lack of it. If you place an explosion in a dense, heavy environment, the surrounding mass will absorb the energy, slowing the outward blast. But if you trigger that same explosion in a vacuum with no mass to hold it back, the shockwave accelerates outward, unimpeded. Cosmologists realize that our local supernovae are accelerating away from us faster than they should, because there is simply not enough matter in our region of space to gravitationally pull them back. To make the math work, to solve the crisis of the Hubble tension, we had to abandon the comfort of the cosmological principle. We had to entertain the horrifying possibility that our galactic neighborhood is profoundly, dangerously anomalous. In a desperate attempt to map our localized gravity, astronomers undertook massive surveys, cataloging the positions and masses of millions of galaxies surrounding the Milky Way. They calculated the weight of our local superclusters, factoring in the invisible mass of dark matter. They cast their nets deeper and deeper into the dark, searching for the missing weight required to smooth out the universal average. Instead of finding the missing matter, they found the wall of the cage. The data returned a chilling geographical map of our reality. The Milky Way, the Andromeda Galaxy, and thousands of our closest galactic neighbors are not drifting through a uniform ocean of cosmic structure. We are plummeting through a localized desert. The mapping revealed that the density of matter drops violently the moment you move past our immediate galactic cluster. We are residing in a spherical pocket of space where the density of matter is vastly, inexplicably lower than the rest of the universe. We had assumed the cosmos was a sprawling, infinite city. We didn't realize we were living in a quarantined, abandoned district, completely isolated from the heavy, bustling architecture of the true universe. But the true terror did not lie in the mere existence of this low-density bubble. The true terror was revealed when astrophysicists finally calculated its physical boundaries, when they measured the sheer, incomprehensible diameter of the emptiness required to generate such a violent distortion in the laws of physics. When the astronomical data finally crystallized, it did not reveal a minor irregularity in the local distribution of galaxies. It exposed a monstrous, gaping wound in the architecture of our reality. The emptiness isolating us is not a mere gap between neighboring star clusters. It is an astronomical feature so incomprehensibly massive that human language lacks the vocabulary to properly convey its scale. We call it the KBC Void, named after the three astrophysicists, Ryan Keenan, Amy Barger, and Lennox Cowie, who systematically mapped its terrifying boundaries in the year 2013. To grasp the true dimensions of the KBC Void, we must abandon the localized metrics of miles and kilometers and adopt the speed of light itself as our measuring tape. Light is the absolute speed limit of the cosmos, racing through the vacuum at nearly 300,000 kilometers per second. At this velocity, light can travel from the Earth to the Moon in little more than a single second. It can reach the Sun in 8 minutes. If you were to point a laser at the center of our Milky Way galaxy, that beam of light would travel for 26,000 years before hitting the supermassive black hole at its core. These distances are already staggering, stretching the limits of human comprehension. But the KBC Void swallows these distances whole. The void is a spherical expanse of desolation, stretching roughly 2 billion light-years in diameter. If you were to stand on the edge of this abyss and beam a radio transmission across it, the signal would plunge into the dark and travel for 2,000 million years before reaching the opposite shore. When that signal first left your transmitter, the Earth would be a hostile, barren rock, devoid of even the simplest multicellular life. The dinosaurs would rise, rule for hundreds of millions of years, and be violently extinguished, all while your transmission was still silently crossing the halfway point of the emptiness. Think of it as the ultimate delay in a global network. If the universe is a sprawling, interconnected system of gravitational information, our local region is operating with a 2 billion-year latency. We are a severed node, functioning in profound isolation from the true, heavy machinery of the cosmos. Discovering an anomaly of this magnitude was not the result of a single dramatic observation through a telescope eyepiece. It was a cold, grueling triumph of statistics, geometry, and industrial-scale astronomy. To map a void, you cannot simply look for darkness. The night sky is already dark. To prove the existence of an absence, you must meticulously catalogue the presence of everything else and mathematically prove that a massive percentage of reality is missing. This endeavor required turning our most powerful terrestrial observatories into machines of relentless, automated cartography. Astrophysicists utilized massive optical instruments, like the Keck Observatory, sitting atop the freezing, dormant volcano of Mauna Kea in Hawaii, to peer into the ancient depths. But they were not taking photographs. They were capturing spectra. When you capture the light from a distant galaxy, you are catching ancient photons that have traversed the freezing vacuum for millions of years. By feeding this light through specialized instruments, astronomers shatter the beam into its constituent colors, creating a barcode of light. This barcode reveals the chemical fingerprints of the stars burning inside that galaxy. But more importantly, it reveals the galaxy's velocity. Because the universe is expanding, the light waves traveling toward us from distant galaxies are physically stretched out, their wavelengths elongated toward the red end of the spectrum. By measuring exactly how far these chemical barcodes have been shifted into the red, astronomers can calculate exactly how fast a galaxy is moving away from us, and consequently, exactly how far away it is located. It is a brutal mechanical process. Robotic arms precisely position hundreds of fiber optic cables on massive metal plates, each cable aligning with a single pinprick of light from a distant galaxy. Night after night, year after year, astronomers harvested the light of millions of galaxies, calculating their distances, their mass, and their exact coordinates in three-dimensional space. They were weighing the local universe. And when Keenan, Barger, and Cowie analyzed this colossal data set, comparing the density of galaxies in our immediate vicinity to the density of galaxies billions of light-years away, the mathematics revealed a merciless truth. The volume of space encompassing our Milky Way, our neighboring Andromeda galaxy, and thousands of surrounding galactic clusters suffers from a catastrophic deficit of matter. The data dictates that the KBC Void is underdense by roughly 20% compared to the cosmic average. In the realm of terrestrial statistics, a 20% deviation might seem manageable, but on a cosmological scale, across a sphere 2 billion light-years wide, a 20% deficit represents a physical absence that defies reason. We are talking about hundreds of thousands of missing galaxies. We are talking about billions of missing stars, uncountable planetary systems, and entire oceans of dark matter that simply do not exist within our local bubble. If the standard universe is a thick, impenetrable fog of cosmic structure, we are sitting in a massive, crystal-clear clearing, entirely unaware of the dense, crushing atmosphere that exists beyond our horizon. But the sheer scale of the void is only a fraction of the mystery. The true psychological terror lies in our exact geographic placement within it. We are not located near the edge of the void, looking out at the dense walls of the true universe. Through an agonizing twist of cosmic probability, our Milky Way galaxy is suspended incredibly close to the absolute dead center of this 2 billion light-year sphere of nothingness. This perfectly centralized position is the reason we were blind to our imprisonment for all of human history. If we were located near the boundary of the void, the night sky would present a glaring, undeniable asymmetry. One half of the sky would be packed with an overwhelming density of ancient galaxies, blindingly bright and clustered together, while the other half would be a terrifying pitch-black expanse of empty space. Our ancestors would have looked up and immediately understood that we existed on the edge of a great cliff. But because we are marooned in the geometric center of the void, the emptiness surrounds us equally in every single direction. The optical illusion is flawless. The sparse, scattered galaxies that do exist within our local bubble are distributed just evenly enough to trick our localized perspective. We look out, see a uniform smattering of stars and galaxies, and naturally assume the pattern continues endlessly into infinity. We mistook the ambient dust floating in the center of an empty room for the architecture of the building itself. Even our grandest cosmic achievements feel fragile when viewed through the lens of this isolation. In recent years, astronomers proudly mapped the sprawling, intricate supercluster of galaxies that we call home, naming it Laniakea, a Hawaiian word meaning immense heaven. Laniakea contains roughly 100,000 galaxies, strung together along glowing filaments of dark matter, all drifting toward a massive gravitational focal point known as the Great Attractor. It is a stunning, beautiful map, a testament to the scale of human observation. But the existence of the KBC void recasts Laniakea in a dark, sobering light. Laniakea is not a foundational pillar of the universe. It is merely a fragile, isolated cobweb hanging in the dead center of an abandoned room. The Great Attractor is not a master mechanism of the cosmos. It is just a localized eddy, a tiny current of gravity shifting the dust within our empty bubble. All of it, our planet, our sun, our galaxy, and our entire supercluster, is dwarfed by the sheer volume of the nothingness that encases it. The mechanics of this void actively manipulate the physics of our reality, directly fueling the crisis of the Hubble tension. To understand how an absence of matter can tear the fabric of space, we must look at the gravitational dynamics of the void's boundary. Imagine the universe as an infinitely large, tightly packed sponge. Now carve out a massive spherical hollow in the center of that sponge. The walls of that hollow are incredibly dense, packed with the heavy, unyielding mass of the universal average. Inside the hollow, the matter is sparse, light, and scattered. Gravity is a relentless pulling force dictated by mass. The dense, heavy walls of the KBC void exert a colossal gravitational pull on everything inside it. The galaxies that make up our local universe are not just drifting aimlessly. They are being physically violently drawn outward, pulled toward the dense shell of the true universe that surrounds us. This outward gravitational rip acts as an artificial accelerator. When astronomers look at our local exploding supernovae and calculate that the space around us is expanding faster than the ancient universe predicts, they are not witnessing a flaw in the fabric of time. They are witnessing the mechanics of our exile. The local universe is flying apart faster because the immense gravity of the void's dense boundaries is actively pulling our surrounding galaxies away from us in every direction. We are experiencing a localized kinematic illusion, where the sheer gravity of the distant unseen walls mimics an accelerated expansion. Dark energy, the mysterious force driving the universe apart, operates unimpeded here. In a normal, dense region of space, the gravity of thousands of galaxies fights back against the outward push of dark energy. But in the barren wasteland of the KBC void, there is simply not enough mass to resist. The dark energy dominates, and our isolated island of matter is stretched thinner and thinner, accelerating toward the cold, distant edges of the sphere. The mathematics reveal a merciless truth. The emptier the void, the faster it tears itself apart. Yet providing a local solution to the Hubble tension only breeds a far more terrifying global crisis. If the KBC void is the true cause of our accelerated local expansion, we are forced to confront an observational nightmare that shatters the very foundations of cosmology. According to the cosmological principle, the universe must be uniform. The standard mathematical model of the Big Bang, heavily supported by the pristine ancient radiation of the cosmic microwave background, strictly dictates how matter is allowed to clump together as it cools and expands over billions of years. The math allows for small voids. It allows for minor fluctuations in density, but it places a hard, unforgiving limit on the size of cosmic structures. Under the standard laws of physics, a void measuring 2 billion light-years across, with a density drop of 20%, is a statistical impossibility. The gravitational mechanics of the early universe simply did not have enough time, nor the right conditions to carve out an anomaly of this magnitude. To generate a localized emptiness of this scale, the primordial plasma of the Big Bang would have had to behave in a wildly asymmetrical, violently unpredictable manner, directly contradicting everything we see in the ancient background radiation. The existence of the KBC void is not just an interesting geographical quirk. It is a massive, glowing paradox. The precision measurements of the early universe loudly declare that a void of this size cannot possibly exist, and yet, the meticulous, irrefutable mapping of our local galaxies loudly declares that we are sitting exactly in the middle of it. We are caught between two absolute, mathematically rigorous truths that violently contradict each other. If the background radiation is right, the void cannot exist. If the void exists, the foundational model of the universe is fundamentally broken. Our entire understanding of cosmic evolution, the very equations we use to define the past and predict the future, are suddenly hovering over a conceptual abyss. Astronomers are left staring at the raw data, grappling with a reality that refuses to align. They have checked the instruments, they have recalibrated the telescopes, they have counted the missing galaxies time and time again, desperately hoping to find the invisible mass that would close the wound and restore order to the universe. But the void remains, a silent, unyielding monument to our own ignorance. The paradox we are currently trapped inside is not a simple miscalculation. It is a direct, violent assault on the most successful, rigorously tested mathematical framework in the history of human thought. To grasp the sheer panic rippling through the halls of modern theoretical physics, you must understand the sacred blueprint we call the Standard Model of Cosmology. In the cold clinical language of academia, it is known as lambda cold dark matter. This is not just a theory, it is the ultimate recipe for reality. It is an exquisitely tuned mathematical equation that balances the two most dominant and terrifying forces in nature. On one side of this cosmic scale, you have cold dark matter. This is the invisible heavy anchor of the cosmos, the silent gravitational glue that pulls galaxies together and prevents them from spinning apart into the freezing dark. On the other side, you have lambda, the mathematical stand-in for dark energy. This is the repulsive anti-gravitational phantom force that is relentlessly stretching the fabric of space. For decades, our entire understanding of existence relied on a razor-thin, perfectly calibrated war between these two titans. The mathematics dictate that the universe must be comprised of roughly 68% dark energy, 27% dark matter, and a pathetic, mathematically insignificant 5% of normal, tangible matter, the atomic dust that makes up the glowing stars, the silent planets, and our very bodies. This framework is not a guess. It is a conceptual fortress built upon mountains of observational data. When we point our telescopes at the cosmic microwave background, capturing the dying thermal afterglow of the Big Bang, the lambda CDM model perfectly predicts the size, temperature, and distribution of those ancient thermal echoes. It flawlessly explains how the primordial plasma cooled and coalesced in the deep past. It tells us exactly how the cosmic web of dark matter filaments should look on a macroscopic scale. The math is so elegant, so violently effective at describing the ancient universe, that astrophysicists treated it as gospel. We believed we had finally deciphered the raw source code of reality. And then, the KBC void shattered the foundation. When you take the flawless equations of the Standard Model and ask them to predict the probability of a 2 billion light-year sphere of emptiness forming naturally in the universe, the mathematics simply break down. In statistical science, there is a concept used to measure the extremity of an anomaly, a way to gauge just how violently an event deviates from expected reality. It is a measurement of tension, expressed in standard deviations, or sigma. If an anomaly is minor, the math absorbs it. But as the anomaly grows, the statistical tension tightens like a wire. In the realm of particle physics, a deviation of 5 standard deviations is enough to declare the discovery of a new fundamental particle, an event that rewrites textbooks and wins Nobel Prizes. The mathematics reveal a merciless truth. The existence of the KBC void represents a statistical deviation so incredibly massive that it shatters the scale entirely. To naturally generate a void of this sheer volume and depth under our current laws of physics is the equivalent of rolling a trillion-sided die and having it land on the exact same number every single second from the birth of the universe until the end of time. It is not just incredibly unlikely, it is mathematically forbidden. The Standard Model of cosmology explicitly prohibits the existence of the very space we are currently living inside. We are inhabiting a geometric impossibility. This is the Great Barrier. We have hit the absolute limits of our current physics, and the scientific community is now gridlocked in a brutal, theoretical civil war. If the void is real, and the relentless, overwhelming catalogue of millions of local galaxies absolutely insists that it is, then the sacred recipe of the universe is fatally wrong. Something in our fundamental understanding of gravity, matter, or time is critically flawed. But abandoning the Standard Model is like pulling the keystone out of a massive archway. The entire cathedral of modern astrophysics collapses with it. Desperate to resolve the paradox, rogue factions of theoretical physicists have begun to entertain terrifying alternatives. Some suggest we must entirely rewrite the laws of gravity. They propose a radical concept known as modified Newtonian dynamics. This theory suggests that the gravitational laws forged by Isaac Newton and expanded by Albert Einstein are merely localized illusions. It suggests that on an unimaginably vast cosmic scale, gravity stops behaving like a predictable, steady pull and begins to warp, changing its fundamental nature depending on the acceleration of galaxies in the deep void. It is an elegant, terrifying thought that the gravity binding you to the Earth right now is just a low-energy manifestation of a much darker, wilder force that governs the deep universe. But modifying gravity opens a Pandora's box of new nightmares. The moment you tweak the mathematical equations to explain the giant emptiness of the KBC void, you instantly destroy the math that perfectly explains the ancient radiation of the Big Bang. You fix the local universe by breaking the dawn of time. There is no clean compromise. Other cosmologists whisper that perhaps dark energy is not a constant, steady force, but a volatile, dynamic entity that changes over eons. Perhaps in our desolate pocket of the universe, dark energy has pooled, growing hyper-concentrated and violently tearing our local galaxies apart, carving out the void from the inside out like a cosmic tumor. But introducing a dynamic, unpredictable dark energy means accepting that the future of the cosmos is entirely unknowable, ruled by a chaotic, shifting phantom that we cannot even detect, let alone predict. As the theoretical battles rage in the dark, an even more insidious problem has begun to paralyze observational astronomy. The barrier isolating us is not just a theoretical impasse, it is a profound optical and physical prison. We are trying to understand the grand architecture of the universe, but we are forced to do so while submerged in a massive, distorting lens. Every single piece of information we have ever received from the deep cosmos, every photon of light from a distant quasar, every gravitational wave from a colliding black hole, every faint echo of the Big Bang has to physically travel across billions of light years to reach our telescopes. Imagine the journey of a single particle of ancient light. It travels uninterrupted through the dense, heavy, perfectly normal regions of the distant universe for eons. But eventually, to reach Earth, it must cross the boundary of the KBC void. It must hit the dense gravitational wall of our localized bubble and plunge inward. As this light enters our massive expanse of emptiness, the sheer lack of gravity fundamentally alters its energy. It falls into a colossal gravitational valley, losing momentum, stretching out its wavelength in ways that standard physics struggles to accurately untangle. We call this a kinematic distortion, but the reality is much simpler and far darker. The void is actively warping our view of reality. Think of looking at a sprawling, highly detailed map of a majestic city through a massively curved, thick pane of blown glass. The buildings at the edges seem to bend. The distances between streets appear completely skewed. If you did not know the glass was curved, you would draw terrible, wildly inaccurate conclusions about the size and shape of that city. This is our existential crisis. Because we are sitting in the dead center of an unprecedented gravitational anomaly, our baseline for what constitutes normal space is entirely corrupted. If the void is warping the incoming light, then every single cosmic distance we have ever calculated might be subtly, fatally wrong. The galaxies we thought were 10 billion light-years away might be significantly closer or unimaginably farther. The age of the universe itself, carefully calculated at 13.8 billion years, relies entirely on our precise measurement of cosmic expansion. But if our local expansion is artificially accelerated by the immense gravity of the void's walls, and our incoming light is energetically distorted by the deep emptiness we sit within, then the fundamental constants of nature are suddenly smeared with doubt. Consider the sheer frustration boiling within the astronomical community. Imagine spending your entire life constructing an intricately detailed million-piece puzzle. You have the border complete, the colors are matching, the image of the cosmos is finally revealing itself. And then you reach the very center of the board, right where you are sitting, and you realize the final 10,000 pieces do not belong to this puzzle at all. They are from a different box, cut to a different shape, depicting a terrifying empty black space. The astronomers look at the observational data, the indisputable hard-counted galaxies, and tell the theoretical physicists that the puzzle is broken. The theoretical physicists look at the flawless ancient mathematics of the Big Bang and tell the astronomers they must be counting wrong. It is a gridlock of human brilliance, a paralyzing standoff where both sides possess mathematically irrefutable proof, yet both cannot be right. We mapped out the grand, glowing architecture of the cosmic web, believing our local structure, Laniakea, was a proud, bustling intersection on this cosmic highway. But when viewed through the brutal lens of the KBC anomaly, Laniakea begins to look less like a majestic city and more like a dilapidated, isolated outpost built on a dying frontier. The mathematical models suggest that the heavy, dense filaments of dark matter that are supposed to act as the foundational highways of the universe are fundamentally absent here. We are not tethered to the grand cosmic grid. We are floating adrift, unmoored from the heavy machinery that dictates the ebb and flow of galactic empires out there in the deep. Some theorists have resorted to calling our predicament the Hubble bubble. The mathematics reveal a merciless truth. The deeper we look into our own local environment, the more our localized laws of physics seem to fray at the edges. Inside this bubble, the outward force of the universe's expansion feels overwhelmingly powerful, tearing our local galaxies away from us at an accelerated rate. We measure this terrifying velocity and assume the entire universe is heading toward a freezing, rapid death known as the Big Rip. But what if this apocalyptic acceleration is entirely a local phenomenon? What if the universe outside our bubble is expanding gently, calmly, while we are violently ripped apart simply because we lack the gravitational anchors to hold ourselves together? We could be projecting our own localized doom onto a cosmos that is otherwise perfectly stable. This brings us to the ultimate epistemic nightmare, the true horror of our cosmic isolation. For half a millennium, ever since humanity realized the Earth revolved around the Sun, the entire engine of scientific discovery has been driven by one single, humbling assumption. We assumed that we are not special. We assumed that if you conduct a physics experiment here on Earth, you will get the exact same result if you conduct it in a galaxy a billion light years away. We built our entire civilization, our technology, and our understanding of existence on the unwavering belief that the universe operates under a single, universal set of rules, and that our tiny corner of space is a perfectly average, unremarkable sample of the whole. The KBC Void brutally assassinates that assumption. The Void proves that we are not living in an average, unremarkable patch of space. Through an agonizing twist of cosmic geography, we are stranded in the most extreme, highly anomalous and mathematically impossible environment yet discovered in the observable universe. We are the ultimate exception to the rule. We are the statistical error. And if we are the anomaly, how can we possibly trust our own science? How can we sit inside a localized bubble of broken physics and boldly write equations that we expect to govern the infinite expanse beyond our horizon? We are like deep-sea fish, born in the crushing, lightless pressure of the Mariana Trench, desperately trying to write the laws of aerodynamics without ever having seen the sky. The fish can measure the water, it can calculate the currents, but the moment it attempts to describe the atmosphere, its mathematics are entirely useless because its environment has permanently blinded it to the true nature of reality. The void is not just an empty space, it is a quarantine zone. It is a physical and philosophical barrier that traps our understanding of the universe inside a distorted, localized bubble. We map our stars, we trace our local filaments, and we construct elegant, sweeping theories of everything, entirely unaware that our physics might just be the localized rules of a desolate, anomalous wasteland. We are forced to confront the terrifying possibility that the true universe, the dense, heavy, majestic cosmos that lies beyond the walls of our 2 billion light-year cage, operates on forces and principles that we can never truly comprehend. The instruments we use to measure reality have been calibrated by the very anomaly that blinds them. The barrier is not made of rock or energy. It is an impenetrable wall of warped mathematics, leaving us stranded in the dark, forever guessing at the true nature of the universe, hidden just out of reach. If the void operates as a localized quarantine, warping our mathematics and isolating us from the heavy, bustling architecture of the true universe, we must confront the ultimate, terrifying consequence of this imprisonment. The KBC anomaly is not merely a static geographical feature, a silent, empty room in which we are currently trapped. It is a relentlessly active mechanism. Because the void lacks the crucial gravitational mass required to hold its inner contents together, it is acting as a massive, localized accelerator for the decay of our reality. It is actively dismantling our future. To understand the long-term physics of our isolation, we must look at the deeply destructive relationship between an underdense vacuum and the relentless force of dark energy. In the dense, standard regions of the cosmos, the outward stretching force of dark energy is constantly engaged in a brutal tug-of-war with the inward pulling force of gravity. When galaxies are packed closely together, their combined mass creates a localized gravitational anchor strong enough to resist the expansion of space. This is why our solar system does not expand and why the Milky Way is not currently being torn apart. But out in the vast empty stretches of the KBC void, this cosmic tug-of-war is incredibly one-sided. With a catastrophic 20% deficit in matter, the void possesses almost no gravitational anchors. There is nothing to apply the brakes. In this desolate environment, dark energy does not just win the war, it dominates with terrifying, compounding efficiency. The empty space surrounding our local galaxy cluster is not simply expanding, it is multiplying exponentially. It is behaving like a microscopic fracture in a pane of glass under immense pressure, racing outward, tearing the structural integrity of our local universe to shreds. This localized acceleration triggers a devastating physical phenomenon known as the cosmological event horizon. We are taught that the speed of light is the absolute, unbreakable speed limit of the universe. Nothing can travel through space faster than roughly 300,000 kilometers per second. However, this foundational law comes with a massive, terrifying loophole. While nothing can travel through space faster than light, space itself is not bound by this restriction. The fabric of nothingness can stretch and multiply at any speed it dictates. Imagine a runner sprinting on a treadmill. The runner represents a photon of light, traveling at its absolute maximum velocity. Under normal conditions, the runner easily reaches the end of the belt. But now imagine the motor of the treadmill begins to accelerate. The belt starts moving backward faster and faster. The runner is still sprinting at maximum speed, expending maximum energy, but their forward progress begins to slow. Eventually, the treadmill reaches a critical threshold, moving backward faster than the runner can sprint forward. The runner continues to run perfectly at their maximum speed, but they are inexorably carried backward, eventually slipping off the edge into oblivion. This is exactly what the KBC void is doing to the light of the universe. Because we are sitting deep within an expanding bubble of nothingness, the space between our local galaxy and the distant structures of the cosmos is multiplying at a terrifying rate. As time grinds forward, this localized expansion will force the distant galaxies surrounding our void to cross that critical threshold. The space between us and them will be expanding faster than the speed of light. When a galaxy crosses this cosmological event horizon, a profound and permanent physical severance occurs. Any light emitted by that galaxy will enter the expanding void, attempting to cross the vast emptiness, but the space ahead of the light will be created faster than the light can traverse it. The photons will become trapped in a futile, eternal sprint, losing energy, their wavelength stretching further and further into the infrared, then into faint microwaves, and finally into dead radio waves, until they mathematically cease to exist as detectable packets of energy. The galaxy will simply fade to black. It will not just be out of sight, it will be physically, permanently deleted from our observable reality. Right now, we look up at the night sky and marvel at the billions of faint, swirling galaxies captured by our deep space telescopes. We feel a profound sense of connection to a vast, sprawling cosmos. But this connection is a temporary, highly privileged illusion. We happen to exist in a razor-thin window of cosmic time, where the local expansion has not yet finished its work. We are the last witnesses allowed to look out the window before the steel shutters slam closed forever. The void ensures that our long-term future is one of suffocating absolute darkness. Fast forward roughly 100 billion years. In the grand timeline of the cosmos, this is a relatively short span, a mere fraction of the universe's potential lifespan. By this time, our sun will have long since burned out, expanding into a red giant and swallowing the Earth before collapsing into a cold, silent, white dwarf. But let us imagine that humanity, or whatever we evolve into, manages to survive. Let us imagine we migrate outward, establishing a sprawling civilization around a stable, slow-burning red dwarf star deep within our galaxy. By this point, the Milky Way and our neighboring Andromeda galaxy will have collided and merged, forming a single massive elliptical supergalaxy. Astronomers call this future structure Milkomeda. It will be a brilliant, bustling island of stars, tightly bound by local gravity, safe from the outward tear of the void's expansion. But what will happen when the astronomers of Milkomeda build their massive observatories and point their telescopes out into the deep dark, seeking to map the grand architecture of the universe? They will find absolutely nothing. The KBC void will have accelerated the expansion of our local space so violently that every single galaxy, every quasar, every supercluster that once decorated our night sky will have been pushed beyond the cosmological event horizon. The deep universe will be entirely erased from view. The sky beyond the edge of Milkomeda will be a perfect, mathematically absolute expanse of pitch black. The terrifying reality of this future lies in the complete destruction of scientific truth. The foundational evidence of how the universe was born will be permanently inaccessible. Today, we know the Big Bang happened because we can detect the cosmic microwave background, the faint, lingering thermal afterglow of creation. But in 100 billion years, the relentless expansion of the void will have stretched those ancient microwave photons so aggressively that their energy will drop to absolute zero. The wavelength of that primordial light will become larger than the observable universe itself. The fossil record of reality will be pulverized into nothingness. When the future scientists of Milkomeda attempt to construct a model of the cosmos, they will be crippled by this absence of information. They will be brilliant. They will develop flawless mathematics, they will build exquisite quantum theories, and they will measure their local environment with uncompromising precision. But when they combine their flawless math with their flawless observations, they will arrive at a fundamentally incorrect conclusion. They will look at the utter blackness surrounding their super-galaxy and logically deduce that Milkomeda is the entire universe. They will conclude that their island of stars sits suspended in an infinite, eternal, and completely empty static void. They will have no concept of an expanding cosmos. They will have no evidence of a Big Bang. They will write elegant, mathematically rigorous textbooks declaring that reality is a solitary, unchanging galaxy, and their science will lie to them perfectly. The KBC void will have completed its work, transforming from a physical quarantine into a permanent, unbreakable epistemic prison. The universe is fundamentally an erasure machine, and the void we inhabit is accelerating the deletion process. It forces us to confront a deeply unsettling philosophical dread regarding the nature of information and the limits of our own supposed enlightenment. We pride ourselves on having deciphered the mechanics of the cosmos. We point our telescopes into the deep past, measure the residual heat of the Big Bang, and arrogantly declare that we understand the blueprint of creation. We recognize that future civilizations will be blind, robbed of the evidence we currently enjoy. We pity the astronomers of Milkomeda, trapped in their localized delusion, entirely unaware of the magnificent, sprawling cosmic web that once existed just beyond their shores. But this realization carries a cold, retroactive horror. If the fundamental mechanics of our local universe are designed to violently delete information over time, and if we are currently suspended inside an anomaly that artificially accelerates this erasure, what gives us the right to assume our current view of reality is complete? We sit here, looking at the cosmic microwave background and the faint, distant galaxies, assuming we are seeing the foundational layer of existence. But we are judging the entirety of the cosmos based strictly on the light that has managed to survive the grueling journey across the expanding void. We must ask ourselves what has already crossed the event horizon. What colossal, unimaginable structures, what fundamental forces, what ancient primordial truths about the architecture of space and time existed 1 billion years ago, only to be relentlessly stretched into nothingness before human eyes ever evolved to see them. If the future of our universe is a localized delusion based on missing data, it is mathematically probable that our present understanding of physics is exactly the same. We are not the enlightened masters of a fully illuminated cosmos. We are latecomers to a dying fire, sifting through the remaining ashes, proudly writing encyclopedias about the nature of the wood that has already burned away. The void is not just erasing our future, it strongly implies that our past has already been heavily curated by the mechanics of nothingness. We are trapped inside a massive expanding distortion that deletes the truth and replaces it with a comforting, localized illusion. For thousands of years, humanity has looked up at the night sky and assumed a quiet ownership over the cosmos. We drew imaginary lines between the stars, weaving them into mythologies. We built cathedrals of glass and metal on mountaintops to capture the ancient light. We mapped the sprawling filaments of the cosmic web and proudly pinned our location on the grand architecture of reality. We convinced ourselves that we were the universe made conscious, an integral, connected part of a magnificent, infinite machine. But the KBC void strips away that comforting arrogance. It forces us to confront a reality that is fundamentally indifferent to our intuition. We are not an integral part of the machine. We are a localized error, a statistical ghost trapped inside a massive quarantine zone of warped physics, distorted light, and missing mass. The universe is not a sprawling, interconnected metropolis waiting for our exploration. It is a terrifyingly silent expanse, and we have been marooned in its most desolate, abandoned district. All of our grand cosmological theories, our elegant equations, our profound understanding of gravity and time, they are nothing more than the localized logic of a prisoner trying to describe the entire world, based strictly on the shape and shadows of their own cell. We pride ourselves on our relentless pursuit of truth. We build more powerful telescopes. We launch probes deeper into the freezing vacuum. We desperately try to pierce the veil of the dark. But the void reminds us that some truths are not patiently waiting to be discovered. Some truths are actively running away from us. The emptiness that surrounds our local galactic neighborhood is not a passive landscape. It is an active, relentless mechanism of cosmic erasure. With every second that ticks by, the sheer, staggering lack of gravity in our local bubble allows the expansion of space to push the true, heavy universe further and further beyond our reach. The cosmic event horizon is closing in on us like a silent, inescapable tide. The brilliant galaxies we study today are slowly, inevitably slipping beyond the physical limits of observation. Their light is being stretched into absolute nothingness, their existence permanently and flawlessly deleted from our sky. We are passengers on a severed, drifting raft, moving further and further out into a starless sea, surrounded by a physical mechanism that is meticulously erasing the shoreline behind us. Eventually, the night sky will empty entirely. The remaining light will fade. The grand glowing tapestry of the cosmos we see today will be permanently replaced by a flawless, unyielding black void. Future observers, born into that total, inescapable isolation, will look out into the absolute dark and logically conclude that they are entirely alone in an eternal empty expanse, and their meticulously crafted mathematics will flawlessly confirm their delusion. We are the lucky few, permitted a brief fading glimpse of the heavy structures that lie beyond our cage before the doors are permanently sealed. The void does not offer meaning. It does not offer cosmic closure or profound spiritual comfort. It simply exists, a colossal, silent monument to the staggering scale of our own insignificance. We are drifting through the dead center of an expanding tomb, clinging to the dying embers of a local galaxy, staring out into a cold dark that is rapidly consuming the last remaining light. And there is absolutely nothing we can do to stop it.